Hello, this is the Tepid Coder here. Today I want to talk about standard format, and I want to start using it instead of fprintf as I get into more complex examples. It's a bit more to type, but it is the C++ way to do things, and I think it'd be good to be more idiomatic, if for another reason that it actually offers type safety. So first of all, let's introduce it. Okay, so if I have include format, I'm also going to want to include, if I can type, string real quick, and include IOStream. This is for like standard cout. This is going to be for standard string I'm going to need. And this is for standard format and vformat and format2 and vformat2. Anyway, first things first, let's talk about what this does. So if I just do standard format, let's say, and I give it a string, say this is it's a placeholder there, I say test. What that's going to do there is it's going to return a standard string, okay? It's going to be filled with a string that has this template, but these templates are going to be filled with the parameters I put after. So this is and then test here is just going to be stuck in, okay? So that's kind of cool. And I can put as many of those extra arguments as I want. And that's very similar to just something like, say I have a character buffer and I do, I don't know, let's call it CRA string even, not buffer. I'll say I have 256 characters in there. I don't really need to initialize it because what I'm going to do is going to initialize it anyway. There's a function called sprintf. There's also sinprintf, which is a bit more safe. It takes a size argument, so it's like CRA string, and then the max size you can have. I think it needs to be not including the 0, so 255. And you can do, geez, like, in this case it would be a string, so percent sign s, right? And then we do test, so it'd be, this is a test. So this right here is the format specifier. So I'm saying what is actually going to go here. In this case it's a string, percent sign s. If it were like a floating point value, I'd do an f. And if I only wanted the first two, what do I say? If I wanted the precision to be like 2 decimal places, I could do 0.2f. Okay, and I could even like 0 pad it in front of it. I start with a 0 or whatever. If it's below, if below 0, it wouldn't just start like 0.10. It'd be like 0.10. I could do things like that. The same stuff exists in here, which is really cool. This is the main reason I put off using like standard cout over the years, is just because when I put something like a float in here, the way you actually put the precision is like you actually have to like pipe some kind of standard something or other in here, set it, and like it's annoying. It's a lot more typing. It tries to do type deduction to figure out what to put in here, which is sometimes convenient, right? A lot of the time if you're just using a plain int, right, it's just going to put it in here by doing standard to string with your integer type, right? That's something else you can do to get a standard string. And that's really cool. Like, don't get me wrong, there's some great things about it. But it's not until that we have this right here where I can actually do the same thing, like 0.2f, and I can actually say something like, you know, I have 234. This is actually going to truncate. What should I say truncate? It's going to round down to this precision right here. If this were actually a 7, I had to, let me try this again. It doesn't matter what this is, matter what the next one is. Okay, so if it's 2 digits of precision, it's going to look at the next digit and round up or down. This is a 4, so it's just going to be 2, 2. But if this is for a 5, it would round up, right? 5 or greater should round up, so it should actually give me that. So, I mean, maybe I'll try that real quick. I'll give both examples here. I'm going to comment these out. Anyway, the fact that we have this kind of power means it's worth using this now. The big thing we're missing at this point is the fact that we have to have this string object. And then we're going to do like standard cout and then the string, right? And obviously I don't really need to define the string, but if I just do this right here and pipe that into standard out, it's still making that string object, and then it's copying that string object, or I shouldn't say copy it, but it's using that string object to dump something to standard output, which could be a console, it could be something you're piping into, I don't know, a web server to serve some HTML to a user or something. Whatever, it's going to your standard output. Anyway, that's not great. Thankfully, there is at least something called format2. Now, this will work because all of this is known at compile time. It's a constant expression. I haven't really gone into that yet, and that's kind of cool because you can do some stuff that what do I say? It's optimized in the sense that, if it's constant expression, it's calculated at compile time, basically. So that's kind of cool. Instead of having to make some calculation at runtime and be slow, it does it at compile time. That's cool. Anyway, v, for variable, lets you do this at runtime. And for that, you should be using standard make format args. Okay. And you put the types in here, or the values in here that you want to substitute. Now, you can't directly pipe that into cout, unfortunately. Not even exists then. Let me think for a second here. Okay, so what we can do is we can do standard ostream iterator of type character. Alright. And then we're going to call that out. And that's going to go to cout. Okay. Now what we're going to format to is out, which is this ostream or output stream iterator that's going to pipe into cout. And now everything we format here is going to go to cout. So that's kind of cool. I could probably wrap this in some kind of function or macro or whatever to make this simpler to use. But let's just try this out real quick. Let's compile that. So it does not like ostream iterator. Let me think about that for a second. Right, I didn't actually include iterator. Don't really need that, because I'm not going to use just standard format directly. Even if I did, this probably is including standard string for me, because it can format to a string. Okay, anyway. Test. So you can see 2 digits of precision is 1.22. Let's try and change that, make it like a 5 here and see what happens. I can put an F after to really hammer in it's a float. Okay. 1.23. So you can see it actually rounded up. And it's the same thing that fprintf would have done, or sprintf, or printf, or vprintf, or there's a bunch of them, right? So this is worth using because it has the same functionality. I'm going to show some other things it can do as well. So for each of these, I'm just going to insert a line break. And how about, let's see, we did a floating point number. Let's do a string. So here's a string. And what I'm going to do for the string is I'm actually going to print only the first 4 bytes of the string, the first 4 characters of it, right? Oops. I want this to be in my format args. Format arguments. Okay. So the second one, let's say test and then garbage. This underscore garbage is going to be removed. It's not going to be included in the string because I'm only printing the first 4 characters. Another thing I can do, let's see. So I can pad an integer value. So let's say here's a padded, let's say pre-padded integer value. So, okay, let's do 0, 2. So we're going to pad it to 2 characters with a 0. So if it's a number less than 10, it's going to put a 0 in front of it. So let's try it twice. I'm going to say 9 right now. Let's compile that and run it. Okay, primary expression for the closing parenthesis. So what did I mess up here? We got some strings being concatenated to each other. The next argument is standard format arguments. Well, why did I put a comma here? Oops. Okay. Test. Okay, so you can see it pre-padded it with a 0. You can see it only printed test. It didn't do the garbage afterwards. This is being rounded up or down as needed. And I'll put 10 up here. So it shouldn't need to pad anymore. It'll just be 10. There's not going to be a 0 in front of it. See? So that's really cool. Essentially, you can get the same exact functionality that you would get with sprintf or printf or fprintf or any of the other variations. So I just wanted to show that real quick. And I guess maybe I can show, just real quick, standard string, and I'll do str equals vformat. I'm going to say something like, I don't know, testing 1, 2, 3. And I'll do standard cout, str, standard inline. Just to show you can do it that way too. Actually make a string object out of it. Okay, well it didn't like that. Why is that? Can you string format? Okay, format. Oh, I didn't actually, sorry. If I did this, it would work, because it's constant expression, right? It's a compile time I can make this. Right. But if I wanted to make it work with things that are variable, it happens at runtime. Let's make format args. It's just so much typing for the same result. So, future tepid coder here. So, I was looking through my compiler, seeing which ones might support this. There is something you can do in C++23 called standard print. Okay. You need to include print and to include IOStream. If you do that, you can do standard print, and you can pick if you want. Oh, sorry, not standard out. Standard cout. Come on. Wow. I cannot type. Okay, this is only a placeholder here. And test. And this will work if, inside general here, language standard. Currently the latest officially supported, I guess, is 20, but you can preview features from the latest C++ working draft. And this does have some C++ 23 features. And if I compile this, it does work. Cool. And I was a bit kind of confused when I tried to do vprint. It seems like that doesn't exist. There is a vprint Unicode you can do, but when I checked the documentation, it kind of seems to me like print does not care about constant expression for the format string. Whereas if I go to standard format string does have to be constant expression. Or the format, I mean. So, yeah. Format. Anyway, it seems like you might not have to do the same stuff where it's like, you know, the V version and standard make format args, like that. So that's cool. I could be wrong about that. Maybe I'm misreading things, but it seems like it's completely legit just to do something like something you don't know till compile time. Let's pick a number between, I don't know, 1 and 10, right? If I do mod 10, it's going to be 0 through 9. I'm adding 1 to it, so 1 plus 9 is 10. You know, 1 plus 0 is going to be 1. So that's the range, 1 to 10. I could do sran to see the random number generator with, let's say, time. I'll do null pointer. And I'll, I don't know, static keys. So I cast that to a unsigned integer. And everything should be happy. Yeah, and it looks like it does compile. Oh, I didn't actually use the value, so of course that would compile. Try that again. But yeah, it does compile, it does run it does give me a random number. I can do it again, get a different random number. It's 1 this time, it was 8 previously. So that's cool. Anyway, if anyone has any comments, feedback, criticisms about this, let me know. This is something I, as you can probably tell, don't use very often. Hardly at all, really. So, if there's things about this you think maybe I'd benefit from learning too, by all means, you know, let me know. And as always, I appreciate people taking the time to watch the video. Like, comment, subscribe, all that fun stuff. Catch you later.